Video lesson 11.4, equation of a line. So we're going to deal with here a little bit of review, I hope at least, some linear functions and how they work, specifically their relationships, and what we're going to kind of need it for in a geometric standpoint. So let's just do a little bit of recall here. So again, if you remember the equation of a line, one version is y equals mx plus b form. Again, when it's in this form like it is written right here in these examples, this is standard form. All right, so we do need to be able to manipulate this and get it into y equals mx plus b form. So we're going to take an opportunity to try that right now. There is another form, which I've talked about before, and we will utilize in a lot more depth, later on in this video, but also others, and that's point slope form. So I'm just going to write that at the top. So you got point slope form as well, and that's y minus y1 is equal to m times x minus x1. I personally like this form most often, but again, sometimes the information just is easier or provided y equals mx plus z might be simpler, but again, depends on the context as we get a little bit more advanced. But for right now, I'm jumping ahead. Let's get to this one. So let's just rewrite this into y equals mx plus b form. So if I subtract the 6x here, my goal here is to isolate the y. So I want to get everybody else alone here and everything to the other side. So I'm going to divide everybody by 3. So that gives me y is equal to negative 2x plus 4. Again, so that's my y equals mx plus b form. All right. I like this because it tells me the slope and the y-intercept just in the formula itself. So that's why I like to be able to get it. But again, the key here is to get it, to isolate it. You notice that when I subtract this 6x over here, I can't combine them. They're not like terms. So I always put the x term first, so it's in this nice format. Again, technically, if you wrote 4 minus 2x, it's not wrong mathematically, but again, we like it to be in this form. It just makes it more simplistic and safer when you're trying to find what the m is and the b is. All right, I'm going to let you guys try 3 and 4 on your own, so I'm going to take this opportunity, give you guys a chance to pause the video, come up with those results, and then I'll give you guys the answers. Okay, so hopefully you guys had answers for those. So let's reveal what they are here. So we've got this first one, y is equal to negative 5/7 x plus 2. And for the third one here, we've got y equals 2x plus, 2/5 x plus 7/5. Notice I left the in fractional form because again, the number in the front of the x, that's our slope. We're going to want that as a fraction, so we're going to leave that as a fraction. You could have made 7/5 into a decimal. That's 1.4. Again, that's, either way is fine on that one, but I prefer it in fraction form. All right, so moving on. We've got 2 other things that I thought were important for us to be able to kind of reiterate or remind ourselves here. And that is actually graphing these things and some of the information. So again, the reason we like y equals mx plus b form is because it tells us, so in this form, right, we know right away that the m, that's our slope, and the b, that's our y-intercept. So in this question right here, right, we've got m to be the 2 and a b, which equals negative 7. So now I know that I can start at negative 7 on my graph, on my y-axis here. So here's negative 7, right? And I can go up to right 1, up to right 1, or I could go down to left 1. Like I can do as many as I need, and that would give the equation of a line. So if I have here, that would be my line for that one. So I'm going to write that here, y equals 2x minus 7 for that one. And I can do the same thing over here. So in this example, my slope is -1/2. My y-intercept is 3. So if I go to a 3 on the x-axis here, I'm sorry, a y-axis, I can now go down 1, right 2, down 1, right 2, right, down 1, right 2. And I can keep going, if I needed to, wherever I need to go, however far. And then I can draw my line through those points right there. It does look like I'm a little off on this one. Let me redo that. Try and make that as accurate as possible. That looks a little better. And I notice here, right? Let me also write the equation of that line, since whenever you have two or more equations on one graph, you should label them. So I got the intersections, right here. So this point of intersection, right? That's my solution. All right, so we could do this algebraically, right? I could solve for x here. Once I get x, take x, plug x back into either one of these two equations to find y. But again, since we did it on graph paper already, I can kind of cheat here. I can just see where they intersect. That's at 4, 1. So my solution for this is 4, 1, because that's their intersection. All right, some other important things to know and remember. These two lines, y equals 1, that has a slope of 1/1. Right, that's the line that splits the first and third quadrant right in half. So if you think about it, and part B says some obvious coordinates here. So think about it, it's where y and x are equal. So I got 1, 1, 2, 2, 3, 3, so on and so forth. So that's going to be this line right here. Right, and y equals -1, I'm going to have a -1/1 slope. This is a line that splits the second and the fourth quadrant in the same manner, right? So that's going to be this one over here. All right, so those are two important lines. They're ones that a lot of times we have things in geometry that we want to, we may want to do a reflection over them or something like that. So there are important lines to make sure you know. Like I said here, that the points, the x and the y values are the same for the blue one. Just one of them is negated for the y. All right. From there, there's some other lines that I also think are important. So I want you to jot this down too, and that is what happens when you have y or x equal to a constant. So y equals a number or x equals a number. Well, if it's y equals a number, that makes it a horizontal line. All right. If it's x equals a number, that's a vertical line. So whenever you have x or y equal to a constant, you're either going to have a horizontal or vertical line depending on whether it's equal to x or equal to y. So that's important information to remember. The two most important or common ones are y equals 0, and that's the x-axis. You got to be careful. That's one that usually people mess up a little bit. So we've got y is equal to 0 is the x-axis, and we've got x equals 0. That's your y-axis. So if you don't know those, definitely jot them down because, like I said, that's where people make mistakes often. So like I said, if they wanted to say the x-axis, they could say y is equal to 0. And if they wanted to say the y-axis, they could just say x equals 0. Again, they like these, especially when doing like reflections or other things like that. Instead of actually just saying x or y-axis, they might give you the equation format. So those are important pieces of information to know as well. All right, example 2 here. How do we utilize this? So if they want us to draw a line that passes through the point 2, 4 and is parallel to the line that we have there, which is S. All right, so in order for it to be parallel, we know that the slopes must be equal. So let's find the slope of S, right? Now pick 2 points that are nice. Again, try and pick the clearest, most accurate points that you can. So in this one here, I'm going to pick the x and y intercept because they seem to be really nice, clear points. If I count those boxes here, I've got my rise over run. So I've got down 4, right 8. So -4/8. That's going to be -1/2. So if the slope of S is -1/2, that means my new line, right? So this is, I'll do it over here. So m is equal to negative a half. That means my parallel line slope is also going to be 1/2, right? And this is key piece of information. I also need to know the point that it's going to go through, and we do. That's 2, 4. That's this one right over here. So I could use y equals mx plus b form to come up with this, but again, as I mentioned earlier, point slope formula is sometimes a lot easier to work with. Yes, you got to memorize the formula, but look, I have a slope and I have a point, so I can plug that in. So if I take my formula again, y minus y1 is equal to x times x minus x1. I can now just simply plug this information in. x1 and y1 are my points, so this is x1, this is y1. Here's my slope, negative a half, so I just plug that information in. So we've got y minus 4 equals the slope, which we've got here as negative a half, times x minus, and the x coordinate was 2. So if I do that, I'm done. All right. I mean, I might have to simplify that sometimes. I might have like minus and negative and have to simplify that to a positive or something, but otherwise I'm done. This is the equation of my line. All right. That's going to be the line here that's parallel to S. So it's going to be this one over here. All right. Like I said, the reason I also like point slope formula is because if I do need it in y equals form for some reason, it's a very simple switch. Right, I can very easily manipulate this into it. So just to show you, if I distribute the half, so y minus 4 is equal to negative 1/2 x is going to be plus 1. If I now add the 4 over, right, I'm going to have y equals negative 1/2 x plus 5. So there I go. Here I now have it in y equals mx plus b form. So again, I can utilize that, and it makes it, pretty easy to kind of manipulate if I needed to. But the format wise, it was much easier to get into y equals mx plus b. Point slope formula, this one here, rather than y equals mx plus b form to start. So that's one reason why I like it. If we look at part B, we're looking for the perpendicular. Again, notice and remember that perpendicular means opposite reciprocal. So slopes are opposite reciprocals, or sometimes referred to as negative reciprocals. So again, if we find the slope, so let's find we know that the slope of S was negative a half, right? So the perpendicular slope is going to be, take the reciprocal, so that's going to be 2 over 1, and opposite of negative is a positive, so that's just 2. So now I can again use my point slope formula. All right, and we can plug in the information that we need here. Again, I have my slope, that's my m, and the point 2, 4. So that's going to give me an answer of y minus, let's do it again, as 4 equals the slope, which was in this case 2 now, x minus the x coordinate term, which was 2. And there's my answer. Again, if I wanted to, I could get into y equals 4. All right. Last example here. Which of the following lines is perpendicular? So notice all of them are in y equals form. And I can kind of manipulate these to see which one I figure out is going to be perpendicular. So again, just knowing that their slopes are opposite reciprocals kind of helps me isolate and determine this. So let's get this into y equals form, and that'll help me determine my slope of this line. So if I minus this over, I've got 6y is equal to negative 10x plus 12. Divide everybody by 6. So y is going to equal, was it negative 5/3 x plus 2. So again, here's my slope. So m is equal to negative 5/3. I want the perpendicular slope, which is going to be a positive 3/5. All right. So I could continue working here, right, and try to figure out the equation of a line, but look at the answer choices. My first thing is, let me see if I can just isolate the answer based on this fact, right, the perpendicular slope. There's only one choice here that has a slope of 3/5, and that's number 4. So that's my answer. All right, I don't even have to try and find the y-intercept in this example because there's only one choice that has it. So whenever I do that, I always look for the slope first. Now, if I have more than one, then I gotta get a little creative, figure out a way to isolate or identify what the intercept is, and then create the equation itself. So, but not in this example. I'm good there. All right, so take the opportunity to go back over anything that with the video that you're not sure of. Maybe need to do a little bit more, and don't forget to work on the practice problems for more understanding.